Okay,
Okay.
so here, okay, we'll talk about the landslide, okay, the landslide. Okay, okay, may I recap what we talked about yesterday? So, then, yes. Okay, yesterday we talked about the relief of Hong Kong. So, Hong Kong, okay, has some tall hills like Tai Mo Shan, Ma On Shan, Lantau Peak, etc. And since Hong Kong has a hilly relief, landslides happen frequently in Hong Kong. Okay, so two-thirds of the areas of Hong Kong are hilly. Okay, so mainly in the central and eastern New Territories. Okay, so here, let's. Okay, so what is a landslide? It's the pull of gravity. Everyone remember the key term, pull of gravity. Okay, because of the pull of gravity, okay, a large amount of soil and rocks fall. Okay, and because of the pulling force, soil and rocks flow down. Okay, so what are the impacts, okay, of landslides? First of all, it can cause casualties. Many people die, okay, and injuries. And it can block roads because the mud here, as you can see, can block the roads. And also, it can damage buildings and cars, vehicles. And this is a kind of economic loss. Okay, here, the road is blocked by the falling soil and rock debris here. Okay, so landslides caused more deaths in the early years because in the early years there were not many measures to stabilize the slopes in Hong Kong. Okay, so this is what happened at the mid levels in Hong Kong. Po Shan Road landslide in 1972. Okay, here. And this is what happened in the squatter area in Shao Mao Ping. Okay, landslide in 1972 as well. Okay, so why do landslides occur in Hong Kong so often? First of all, it's due to slope stability. Okay, so because of the shear stress, okay, the gravitational force, the gravity pulls the soil down, and this is the shear stress. Is and the shear stress comes from gravitational force. Okay, it's it's the force to pull Earth's materials down the slope, going down. But at the same time, uh, the soil has cohesion, and then the land has friction. Okay, what is friction? The friction, that means when you lose your balance, okay, and you may scrape your legs or ankles because of friction more tightly. So the cohesion and friction hold slope materials together. So these two forces determine whether a landslide will happen or not. So when the shear stress here is greater than the shear strength, Earth's materials on the slope become unstable. Now, so this term, please remember, shear stress is greater than the shear strength. Okay, so a number of several natural factors can cause a landslide to happen. The first factor is heavy rainfall. The rainwater increases the weight of Earth's materials. Okay, so here is the normal condition. Okay, so you see the soil particles is that large. Okay, and then friction and cohesion hold the soil particles tightly together. However, after the heavy rainfall, you see the links, okay, the links between the soil particles are larger, the space, okay, you see the larger space between the soil particles. As a result, the friction and cohesion is reduced and it becomes loose. And this will cause landslide to happen. So pores means the space between soil particles are filled with water. Here you see. So friction and cohesion decrease. Okay, so now this is the case, okay, which happened in 2008, okay? On the 7th of June 2008, okay, many landslides happened in different parts of Hong Kong. And you see here, okay, at the Lantau area, okay, the rainfall was over 600 millimeters per hour. So you see the areas with heavy rainfall, okay, has had many cases of landslides, okay, heavy rainfall, heavy rainfall, heavy rainfall. So landslides are concentrated in areas with rainfall over 200 millimeters, okay, here and there. So apart from the heavy rainfall, hilly relief is another factor which can cause landslides to happen. The steeper the slope, the larger the shear stress. Okay, so here, okay, now the steeper the slope, okay, the gravitational force is stronger. Okay, that's why the shear stress is stronger. Okay, so the steeper the slope, the stronger the gravitational force. As a result, the shear stress is larger. And then 60% of the slopes in Hong Kong is about 20 degrees. Okay, now the higher the degree, the steeper the slope. Okay, so let's look at the pie chart. Okay, now 40% of the slope is below, 30% of the slopes are below 20 degrees. Another 40% are between 20 to 30 degrees. And then here, 20% are between 31 to 45 degrees. And less than 1% of slopes are more than 45 degrees. So these two are prone to landslides because the slopes are steep, okay, here. So this can increase the risk of landslides, okay? So another factor which can cause landslides to happen is the granite rocks, okay? So what is this, okay? Now granite, Fa Gong Am, is the main type of rocks in Hong Kong. So what's special about granite? Now the granite has a well-jointed structure. You see many joints, okay? These are the joints, granite, okay? But granite is easily weathered. Like weathered means 風化. Well, what will happen? Okay, if weathering happens, what will happen to the rocks? Okay, and then the weathering process is faster under hot and wet climate. Okay, so these joints, okay, when it rains, rainwater seeps into the joints. As a result, you can see the pores, okay, between the joints. And then because of this, the cohesion and friction decrease, okay? And then here, the rock, because of the rainfall, the rock is broken down into a layer of loose weathered materials, okay? Loose weathered materials. The cohesion and friction decrease. As a result, landslide, okay, will happen easily during heavy rainfall in Hong Kong. And then human factors. Natural slopes are cut or filled to create more flat land for urban development. Now here, now this is the original slope, okay? But here we have to create a piece of flat land for the building of this mansion. As a result, you see like the natural slope is not so deep, it's not so steep. But here, the artificial slope is much steeper, and this has increased. This will increase the chance of landslide. Okay. So here, many man-made slopes are poorly designed. Okay. So this is a vertical slope. Okay, and this will increase the risk of landslides. Now, this is a man-made cut slope. Okay, then you don't see any okay, there's some sippages, okay, to release the rainwater, but there are not too many sippages to release the rainwater. So the it is easy for the slope to become unstable. Okay, and then another factor is poor maintenance. Okay, so there is a lack of regular maintenance on some man-made slopes. Okay, and then the damaged or cracked slope surface will okay, in some man-made slopes, the slope surface is cracked. As a result, rainwater can seep into the rocks or the soil, and then in some man-made slopes, the drainage channels are blocked. As a result, rainwater cannot go away quickly. Okay, so this will increase rainwater infiltration somehow. Okay, rainwater seeps into the soil, and then this will increase the risk of landslides. Okay, you see the cracks, so the rainwater can seep into the slope. Okay, so now I will show you an animation to demonstrate how, the causes of landslides in Hong Kong. Wait for me, okay? Now, this is the cause of landslides in Hong Kong. First of all, so it's not this one, not this one. Not this. Okay. Yes. Okay. Now, first of all, granite. Okay, can you? Okay, so here let me see first yeah. Now, first of all, the granite, which is the most common type of rock in Hong Kong, is easily weathered. Okay, and then the rainwater produces a layer of loose weathered material on the top. Okay, so the risk is increased. Next, and then heavy rainfall increases the weight of soil and the pore pressure between soil particles increase. Okay, the pore pressure. And the third factor is development of slopes. Okay, produce cut slopes, and these cut slopes are steeper. As a result, they are more unstable, less stable. And then soil particles are more likely to move down slope, okay, on steeper slopes. As a result, landslides happen, okay? Okay, so let us go back to the revision. Sorry. Okay, so let us go back to the revision first. Okay, so Okay, so I'm going to ask you the question. Okay, when the what? Okay, when theta A is greater than the theta B, so what is theta A? Please answer the question. When theta A of a slope is greater than the theta B, a landslide occurs. So can you tell me what is theta A and what is theta B? Please type it. Okay. What is theta A and what is theta B? Hurry up. Please type your answers. What is theta A and what is theta B? Okay, so theta A, maybe, okay, let me check the answer. Okay, theta A is, okay, shear stress. And theta B is shear strength. Okay, so what is this? What is this? The cloud, what is this? Okay, and what is the name? What is the adjective for this slope? Okay, so can anyone tell me what is this? Okay. Oh, you can't see the screen. Oh, let us see the screen again. Can you see the screen? Okay, here. Okay. So please type the questions. Okay. Can you see the screen now? Okay. So please type the answer. Okay, so let's check the answer now. Okay, so let's see the answer to the conversation. Yeah, so now let's see. Okay, so here, heavy rainfall, good. And then this is the steep slopes. And this is the man-made slopes. Okay, man-made slopes. And man-made slopes are poorly what? Are poorly, it begins with an M. A poorly, what's the answer for the man-made slope? Okay, what's the answer? Let me see it. Made. Okay, what kind of made? So let's check it. Is maintained. Okay, it's maintained. And then here, what kind of rocks? What kind of rocks that I've just mentioned? What kind of rocks here? Yeah, granite. Let's see whether it's granite or not. Yes, granite. Good, excellent. Granite rocks. Okay, so how do we respond to landslides? Okay, so before we talk about the landslide, I want to talk about the slope gradient. Okay, now the slope gradient, I will show you the screen. Okay, slope gradient. Slope gradient. Sorry, slope gradient. Okay, so let's see the screen. Okay, here. Like how to calculate slope gradient? Okay, now slope gradient is about how steep a slope is gradient is about how steep the slope is. So the patterns of contour lines tell the general relief of its place. So we want to know the steepness of the relief. We use the slope gradient. It's a ratio of the vertical distance and horizontal distance. Now let's look at here. Okay, now the vertical distance between A and B is 100 meters, as you can see. Okay, B is 50 meters, A is 150 meters. So the vertical distance between A and B is 100 meters. So, and then what is the horizontal distance of A and B? So here, the scale is about 1 to 20,000. 1 to 20,000. So 1 to 20,000 means 1 cm to 200 meters. Okay, because 20,000 20,000 cm, 20,000 cm is equal to 200 meters. 20,000 cm is equal to 200 meters. So the horizontal scale is 1 cm to 200 meters. And then the actual distance of A and B, okay, now you can, so here it's about 5 cm, okay, 5 cm on the map, on the paper. Here, 5 cm. So on the map, 1 cm is equal to 200 meters. So 5 times 200 meters. As a result, the horizontal distance is 1,000 meters, okay? It's 1,000 meters, okay? So here. Okay, so here. 100, so the vertical distance over the horizontal distance, so it's 100 meters over 1,000 meters, so it's 1 to 10 or 1 in 10. Okay, so let's look at the scale, okay, of a slope. Now the smaller, okay, the gradient of a place is often expressed as 1 to a x number. Okay, so the smaller the value of x is, the greater is the gradient. Okay, so here, now this is 1.7, okay, or 1.4, 1 to 40. It's quite gentle. As a result, trains can run on such a gentle relief. Okay, and then when it is about 1.20, okay, it's uphill. And then it's 1.10 is too steep. As a result, you need to push your bicycle. And then 1 to 5 is the limit for a car to go up the slope. And then if it's 1 to 2, you have to use your hiking stick. And then it's 1 to 1. It's very steep. You have to crawl on the slope to go upward. Okay? So this is the gradient of a slope. Now another point I want to teach is vertical exaggeration. So vertical exaggeration is the ratio of the vertical scale to horizontal scale of a cross section. So it shows how much, okay, the relief has been flattened or steepened. So what is vertical exaggeration? Is the vertical scale over horizontal scale. Okay, so here, the vertical scale, okay, here, 1 cm is equal to 10 meters. And 10 meters is equal to 1,000 cm. So the vertical scale is 1 to 1,000. How about the horizontal scale? Here is 1 to 4,000. So here, okay, basic maths, and then the vertical exaggeration is 4 times. Okay, so I want to show you the contrast between different vertical exaggerations. For example, now here is C and here is B. So if the vertical scale, okay, if the vertical exaggeration is 1 time, you see the slope looks more gentle. okay? But if the vertical saturation is larger, you see the slope seems steeper on this scale, okay? So vertical exaggeration can really make a slope look steeper, okay? Then, okay, we will go back to the measures to prevent landslides. Okay. Okay, how do we respond to landslides here? Okay, first of all, we can use engineering works. So the engineering works is carried by the Geotechnical Engineering Office, okay, GEO. Now please remember this term, Geotechnical Engineering Office. And then we can provide physical support to steep slopes by building some features like soil nails, okay? These soil nails can prevent rainwater from seeping into the soil. And then we have retaining walls, okay? Retaining walls to stabilize the slope. And then to prevent water infiltration, we can do something. For example, we can cover the slopes with concrete, okay? So if the concrete can prevent rainwater from seeping into the soil. And then we can also drain excess water. We can drain excess water by building weep holes, okay? You see the pipes, the weep holes, okay, for the excess water to flow out. And then the surface channels, okay, for the drainage of excess water. And here, we can build barbed wire to track rock debris from falling down the slopes, okay? And then these are different walls to trap rock debris, okay? The walls to trap rock debris, okay? It's a flexible barrier. Then these are rigid barriers. Of course, we need to do regular inspection and maintenance, okay? So most of the man-made slopes are checked and maintained by the government. And if the slopes belong to private owners, these owners have the responsibility to carry out slope maintenance works. They have to take care of the slopes by themselves, okay? So regular maintenance is needed, okay, to ensure slope safety because the retaining walls or the concrete may crack. So that's why maintenance is needed to make sure the slope is well covered by the concrete surface. And then we can have a better land use planning. Okay, so what is careful land use? What is the use of careful land use planning? First of all, it can reduce the risk of landslides. Secondly, what we can do is to clear squatters on hillsides. Okay, we can clear the squatters on hillsides. For example, in Xiaomao Plain, there used to be a large area of squatters, but this area was prone to a landslide, and it was dangerous for people to live there. And after the clearance of squatters, okay, with vegetations were planted on the surface. As a result, the slope has been more stable. Yeah. So, and then we can do landslide risk assessment for housing projects, okay? For example, here, actually, initially, residential buildings were supposed to be built here, okay? at the beginning, okay, this area was a residential area. However, since the slope, since there uh, was a steep slope below, beside, there was a steep slope beside the residential area. This residential area has been turned into recreational land use, okay, to reduce, okay, the possible number of casualties. Uh, a landslide happens. Okay, so these are the preventive measures of landslides. Okay, so do you have any questions? Okay, about the landslides? Do you have any questions? Okay, so now if you have no question, then we can end the lesson now. Okay, thank you.